guys, so I've picked out a few logarithm problems to go over today. Each problem is using one of the properties of logarithms. So why don't we jot those down over here. The three properties that you can use. Number one, if there's a number in front of a logarithm, you can move it up to there, so it will be log base b of x cubed. So that's property number one. The second property is if you have two logarithms that are added, then you can combine them into one logarithm with the same base, and you can multiply the arguments. So log base b of x times y. And then the third one is kind of like that, but it's with subtraction. So log base b of x minus log base b of y. Subtraction turns into division of one logarithm. Don't write the log twice. It's just log base b and then divide x divided by y. And the base would have to be the same on each logarithm to be able to do these properties. Okay, so we've got these properties. Let's make these a little bit smaller. Now, let's try number one. In number one, this is a pretty common type of problem. They tell you three different logarithms, log base 2 and what it equals, log of 2 and what it equals, log of 3 and log of 5. So they're attempting to get you to do this without a calculator, which is our goal also. So these three logarithms have been given to us. Now they're asking us to find the log of 12. Well, what we have to do is think of a creative way to rewrite the 12 using the numbers that they gave us. So I have a 2, a 3, and a 5 at our disposal. So 12, I can break it down smaller because all those numbers are smaller. I know that 12 is 4 times 3. And that's actually helpful because I know that 4 is 2 times 2 times 3. So this really is the same thing as having the log of 2 times 2 times 3. And now I know from this property, number 2, that if you have multiplication, you can break it apart into separate logarithms using addition. So I can do log of 2 plus the log of 2 plus the log of 3. And so if I take the decimals that they gave me over here and just add them up, I can get the solution to this. Okay, so I just cheated a little bit and did that on my calculator. And, well, what it is it's adding 0.301 plus 0.301 plus 0.477. And that ended up being 1.079 for the final answer. Okay, so now let's try the same type of thing with the log of 300. Give ourselves a little more room. Okay, so same thing. We need to be creative and try to create the number 300 using the numbers that they told us stuff about. Well, I'm going to break it down smaller again, so I'm just going to think first, how about 3 times 100? Now, what I will do is the logarithms that I wrote are base 10 because I didn't write a base. So the 100, that would actually be pretty easy if I thought of it as 3 times, and then 100 is 10 times 10. And let's leave it at that. We won't break it down any farther, even though we could. So what this becomes is the log, and the number 300 is the same as 3 times 10 times 10. And then I know from that same property that we used in part A that I can add log of 3 plus log of 10 plus the log of 10. Now, they told us log of 3 was the decimal 0.477. They didn't tell us the log of 10, but that's because they expect you to know the log of 10. The log of 10 is the same as having the log base 10 of 10, and that would just equal 1, because you're saying 10 to what power equals 10, and that's just the first power. So this is adding 1, and this is adding 1. So our final answer for this is 2.477. And that would work with any base that they gave you. Like, I'll write it up here. If they said log base 3 of 3, that also equals 1. Or with natural logs, the ln of e, that's also 1. Okay? Now, the other type of problem I picked out for today is when they ask you to condense multiple logarithms into a single logarithm. And you do that using the properties, which I copied and pasted over here too. And so if you look at part A, the first thing we have is we have two logarithms that are added right here. So I know that I can combine those into one logarithm, same base, base 2. Oh, and the first thing I have to do is move this 4 right to there. I've got to get that 4 out of my way. So think of it that way now. So now we're going to condense the adding into multiplication. So log base 2 of x times y to the 4th. That takes care of those two. And then we still have minus the log base 2 of w. So then the final thing is that subtraction of two logarithms, like this, becomes one logarithm, and you can divide. So the xy 4th sticks together there, and it gets divided by the w. So this is the answer they're looking for. That's condensed now into one logarithm. Now with this part B, I'm going to go through, I'm not going to forget this time, I'm going to go through and move all the front numbers to be exponents. So like this 4 can move, and the 2 can move. Let's just rewrite that much. So the log base 5 of y to the 6th minus log base 5 of x to the 4th plus log base 5 of w squared. So this is what we have now. Now, I would start with the parentheses, just like you usually would do in the order of operations. So inside the parentheses, there's adding. So we know that those two logarithms can become one logarithm if we multiply. So x to the 4th times w squared. So now we have the other stuff that was in front is still here. We don't need the parentheses anymore because I combined those two logarithms. And so the only thing that's left is subtraction. And we know from our properties that if we have subtraction, we can divide the first thing, so y to the 6th, divided by the second part, which is x to the 4th w squared. So it becomes just like this for the final answer. So you want to get really good at condensing, especially because when you go on to solve logarithm equations, it's always best to have it condensed so that you don't have a whole bunch of logarithms on one side. You can always condense those down to one logarithm on each side. But we could do that. We can do solving logarithm equations in a different lesson. And that's it for today.